In this video, we're going to look at some examples of the definite integral. And the first example we look at is find the integral from 1 to 0 of 2x cubed dx. And we'll take a look at that. So the function we were given was, so we were looking to compute the integral from the limits of 1 to 0 of 2x cubed dx. So there's my problem. When I'm starting my solution, I'm going to open the square brackets, indicating that what's inside the square brackets is the function integrated. So it's going to be 2 times x to the power of 4 all divided by 4. And write my limits in. So what's inside the square brackets is actually integrated, and I can simplify that further. I'll just simplify it down to 1 over 2 x to the power of 4, and my limits that I need to substitute are the top limit is 1 and the lower limit is 0. So opening my round brackets is half times 1 to the power of 4 we know is just 1, minus half times 0. So we end up with the final answer of 1 over 2 half. Okay, so that's the first example. Let's take a look at another example. Second example we have is compute the following integral, giving your answer in exact form. And the form is a over b plus ln c, where a, b, and c are all integers. And the integral we have limits from 4 to 1 of the square root of x plus 1 over x dx. So we take a look at this problem, and the problem is we're going to look at the integral from 4 to 1, square root of x plus 1 over x. Now again, we will use the formula book, but we need to rewrite this problem so we can use the formula book formulae. So I write the square root of x in power form, x to the power of a half, plus 1 over x dx. I'll put my brackets in there. Okay, so start the problem, open the square brackets. So x to the power of a half becomes x to the power of 3 over 2. It's a half plus 1, divided by 3 over 2, which is, if I divide by 3 over 2, it becomes 2 over 3. And the integral of 1 over x is ln x. And I write my limits. 4 is the upper limit, and the lower limit is 1. So subbing in my limits, I have 2 over 3 times 4 raised to the power of 3 over 2, plus ln 4. And then I'll minus the lower limit is 2 over 3. Subbing in 1 plus ln 1, which I know is 0. And that simplifies to, so we will have 4 raised to the power of 2 over 3 is 8. It's 16 over 3. 16 over 3 plus ln 4. And then we have minus 2 over 3 plus 0. So the final answer, I'll bring it together. 16 over 3 minus 2 over 3 will give me 14 over 3 plus ln 4. And that's in the exact form as required. A over b plus ln c. So a is 14, b is 3, and c is 4. So that's the second example complete. Now let's look at the final example in this video. So compute the following integral. The integral of pi over 2, the integral from limits pi over 2 to 0 of cosine x minus sine x dx. So we'll take a look at this one. And this time we're going the integral pi over 2 to 0 cosine x minus sine x dx. So open square brackets. So the integral of cosine is positive sine, and the integral of sine is negative cosine, so we're going to have negative cosine. And we put the limits in pi over 2 and 0. So I just tidy that up. So we have sine x plus cosine x. Now these limits, we sub in pi over 2. We should know these values. If we do need to use the calculator, make sure it's on radians. So the sine of pi over 2 is 1. That should be the round bracket. Just go back there and do that again. So sine of pi over 2, sine of pi over 2 plus cosine of pi over 2. We know cosine of pi over 2 is 0. And then minus sine of 0, which we know is 0, plus cosine of 0, which is 1. So we end up here, we've got 1 plus 0 minus 0 minus 1. We end up with the net result of 0. So that's the final example in this video. So thank you for watching, and I'll continue integration in the next video.